So in contrast to the Audioline 345, we're having an immaculate Uniden Uniace 300. So we've got to hope and pray that this hasn't had any messing abouts. And so the reason we're doing this out of sequence, because this is job number 31, lucky customer, is that I need to see how the public address feature is wired to finish the audio line and the low power. So we'll kind of do this at the same time so that that job can go back. So I don't know which video is going to get published first. There's 2 screws missing out of the back, so we'll sort that out. Please, oh, these are, somebody's put self-tappers in the top. They're not supposed to be self-tappers. So it has had the bad treatment, even though it looks immaculate. So there's the 4 capacitors that have to be changed on these sets, and then it'll be the power supply capacitors, and it's come with an old-fashioned plug which will need changing. Right, lid off. Please don't let there be any illegal boards lurking. So looking at this, we've got an orange and a yellow wire which goes to high-low power, and then we've got the wiring for the public address stage. So I'll have to take the bottom off because we've got to change those capacitors. Well, actually this is going to get finished first, isn't it? Because I need to fix the other set by using information learnt from this one. These customers are all within 100 miles of here, so these 3 base stations are going back personally. So I don't want to, especially that Midland, I don't want it to go in the post. It's not the compensation which you might get if it goes missing, it's the fact that it's gone missing and it's difficult to replace. I don't know what that diode's there for. Never seen that before. It's had a crystal filter put in. Oh, hang on a minute. This is factory. So this is the later version, isn't it? Yeah, this is the later version with the crystal filter. So that's why I've not seen that variant. I've no idea what the diode does, and my service information won't be relevant to this version. So before we start, we will run it on the power supply, not the mains power supply that is built into it, and then we can see what current's being drawn. So switch that to DC at the back and plug the test equipment in. So what I'm going to do, I'll zoom in with this, the overhead camera is broadcast quality. I'm going to zoom in on those switches with this camera, then we'll take some stills off the video, and that way we're able to see what the wiring is for the other set. So the audio line is theoretically first, but in practicality it isn't. So we can remember some of all this setup procedure. I'll use our microphone rather than the customer's to set it up. Wherever I've put the microphone, it's the mic that says test mic that says Uniden on it. Now I've got an audio line mic here, which will be off a mobile. We'll take, when we do the on the air test, we'll listen to that. Right, so mic's on, power supply's on, radio's on, it's on channel 19. And what we're going to do is we're going to see how this performs right now. Oh yeah, he's got a bar out on channel 40. He said about that. Well, I think it's better living with that than us trying to 30, 21. Yeah, it only affects channel 40, so oh, I can't tilt it up when it's on external power. Had an LED fitted, don't exactly like LEDs on vintage sets, but at least it isn't blue. So with the set on channel 40, we will. Oh no, we're going to do a performance test first, as it is. So this is the Uniace 300. So let's look at transmit. Are we on picture in picture? We are. So this one's doing 3.9 watts. Deviation is wallow. Why haven't we got any? Mic gain down. Wallow. That's strange. Testing 1 2 1 2 1 2. We've got no transmitted audio. You're not telling me my mic's packed up. He did say people were saying his audio wasn't right, but I said take it with a pinch of salt. Testing 1 2. No. So the radio is not doing any audio. So deviation 0, frequency, which you can't alter on these sets, unless you can on this later one. Let's have a look. No. 2779135 is pretty spot on. So there's nothing we can do with that, and that's fine. And receive. So we'll just have to plug the test gear into the aerial socket. So while we're plugging that into the aerial socket, wouldn't it be sensible if I also plugged our wall-mounted external speaker into the PA socket, and then we can see whether the lack of transmitted audio is in what part of the circuit. There we go. So we'll go over to the Synad meter. Just check we've got RF gain on full. We have. Check the signal generator on frequency. Just trim that very slightly. Set's doing 2.2 microvolts for 10 decibel Synad. It's not particularly good, is it? Now that can change if I change the tone button. No, it's in the better position. Right, what we'll do now, we'll go to PA. Testing 1 2 3, testing 1 2 3. So we've got no audio even on PA. So we may as well find out what's wrong with the audio. So look for the obvious, like wire off the microphone socket. Look for the other obvious, like wire off the mic gain socket, switch I mean. No. So I'll key it up and inject my finger into mic gain, if that's how it works on these. Or the mic. Nope. So we don't have a circuit for the base station, so we have to rely on the realistic service manual for the 2000 and 2001. And obviously there's going to be some differences, but how the PA is wired. 2000, yeah. So basically it goes in to this IC for speech processing. So on pin 3 I should be able to inject my finger. And I can. Not very loud though. And on, this is such a bad photocopy, on pin 7 that should be the bit that goes out. That capacitor's nearby. Capacitor 90, is it? If that capacitor was short circuit, then there'd be no transmitted audio. That's capacitor 101. So I'm barking up the wrong tree. Capacitor 101, if I can find you, I just cannot see capacitor 101. So it may be a different layout on this board. 101. No, 81. 103. Well, I cannot find 101 on the printed circuit board. Let's see whether we've got 101 on this. It could be 81 or 91, to be honest. It's going to be 91, isn't it? That's where I'm. It's because it's a scan of a photocopy. Back to the right one. Yeah, instead of it being 101, it's either 81 or 91. Anyway, it's 22 microfarads. So if we've got 22 microfarads, which we have at 91, we'll turn the radio off and we'll go and get a capacitor and change it. So I've changed the first of the capacitors, 91, and it wasn't that one. I've changed the second one of the capacitors. Because several could cause this problem. So 91, need to look at the layout, don't I? So I've changed 98, that's the one that's affected the cure. I can't, it's such a bad photocopy, I can't tell. I think it's that one. Anyway, so the first one I've tested should be 22 microfarads, and the tester says it's 3 point something microfarads. The second one I've tested, this all surprised me because this isn't a high hour set, not like the Audioline. So that's reading 1 microfarad instead of... Oh, it is 1 microfarad. It reads fine. It reads absolutely fine on the tester, but it doesn't work. You couldn't make that up, could you? But there you are. We have these testers and that, and sometimes it's not proving everything. So now we'll put the radio back onto CB mode, and we should have transmitted audio. Wallow, 1 2 wallow. So now it's 3 point something, it's just over 3, so it needs to come down a bit. So it's 3 microvolts, 3 kilohertz, so it needs to come down. Right, so we'll go through this. So it's now working enough for us to start doing an alignment. So it wasn't that he had a problem with his audio on transmit, there was no audio on transmit. So that wasn't clear from the, well, I didn't read that into it. So, borrowing one of Mr. Chippy's inevitable, I don't know where his green one's gone, so we'll have his yellow one now. So put that on a suitable earth point, that coil will do nicely. So we want to go to the test point 1, which is that resistor there, on channel 40, and on transmit have 3.5 volts. Look at that, 3.58. No adjustment needed. If it needed adjustment, it's the VCO coil there, the first one. Wow. That makes a change, doesn't it? So we should be able to zip through a tune-up on this. Especially if I could find a trimming tool. So back to channel 20. Turn my monitor radio off. So it's warmed up, it's about 3.6 watts. There we are, 4 watts. Good. So let's see where low power is. It's 0.5, so we'll just pop that down to where it should be, at 400 milliwatts. There we are. Another thing done. Now I need to see where the meter is, and it's a bit higher than it ought to be. I can't really tilt this setup or it's going to go off, which is a shame. I can't show you that. RF meter, we'll just turn that to get the 4, which is there. Deviation, get the oscillator out using the Korg chromatic tuner. Making sure mic gain's at full. Just a little bit high. See where that is. Wallow, 1 2 1 2 wallow. Spot on. That's it. We're done. Transmit's done. How easy. Now receive. Honestly, it sounds off frequency. It isn't. So let's listen. Let's have a look at the oscilloscope. Wherever that's gone. There it is. Switch the bench light off. 100 microvolt signal. S9 equivalent. And we'll set that detector which is actually out. So that's a positive step. So now we'll go over to the synad meter. We'll run through the front end. So I've got as little signal on as I can, about 4 dB on that meter. Wow, what an improvement. But something's dreadfully out. this point we've got 1 microvolt for 12 decibel cyanide, which is probably where we'd expect it to be on a Uniden set. That IF was absolutely totally out of kilter. But you know what? I'm going to change that capacitor. Just in case. Because you just don't know whether it's had the golden screwdriver. And for about the 20 pence this costs, I think we'll get it changed. So, what is it? It's 1 microfarad. Yeah, it's not normal, but there we are. So I'll get a new one of those. So we've got the other 4 capacitors to change, that, and that, but they shouldn't affect alignment. I'll tell you what though, once I put this in, I'll do those 4. Now it doesn't have that other tuning point now. It only has the 1. So that's better. See what the cyanide reading is now. Yeah, it's still 1 microvolt. But that had a false tuning point, and now it doesn't. So that's good. So I think what we'll do is pause the video. I'll change that, and that, as we have to on these sets now they're this age. Okay, so I've changed the usual culprit capacitors, 470 microfarads, the 220 and the 220 there, and I've changed the 3 power supply capacitors. These 2200 ones from RS, I've used 3 this week and I only buy 2 at a time, so we're now wiped out of those. Plug will need changing. I've checked the wiring. It's got a 5 amp fuse in, which is better than a 13 amp fuse, but as I've said on the Audioline, these power supplies run all the time, so whenever this radio is plugged in, this power supply will be developing 13.8 volts or whatever, whereas on the Midland, I thought it worked that way, but it doesn't. It goes through the on and off switch on the front, as does the 12 volt one. So, not ideal. So just be aware of that if you've got an Audioline base station. If you switch it off at the mains overnight, this is drawing current, even though the set isn't actually on. But I'll tell you what, we'll put it on the thingy meter, and we'll see what current it draws when it's not on. So we need to set this power supply up. So I've been running the set at 13.8 volts, and the radio is developing a full 4 watts at 13.8 volts. So let's see if we can set the power supply up to 13.8 volts, because the Audioline one I've just done, I couldn't get it under 14.1. So that's negative. 15.4. It's been turned to full whack. No wonder it needs the capacitors changing. You can't see that, can you? So set it at 13.8, switch the radio on, and I've got to switch that switch at the back to AC from DC. There we go. And what we need to just check is on transmit, it's still doing 4 watts. So it's just slightly over the top. So it's actually supposed to be 13.2 volts, this power supply. So we'll just see whether we can get closer to that with the right transmit power. Let's try it at that. Now it needs to come up a bit from that. Spot on. See what it is on the band edges, because they don't balance like the Cybernet. Yes, 4 watts all the way through. That's excellent. Especially considering it was, if the power supply was running at 15 point something volts and only developing 3.9 watts. Mind you, we were testing that on the external power supply, weren't we? So that just leaves the meter, which I can show you now. Check those are at full. So as you can see, we haven't got S9 for an S9 signal. I've got 100 microwatts on the signal generator, but no S9. So just need to pop that up. SM signal meter. There we go. So now we just need to do the squelch and then we're done. So turning the squelch to full, and the squelch is set far too high because it's squelching out S9. Now these are a bit stronger than I would like, and this set maximum squelch is 800 millivolts, but there's nothing I can do about that except set it to the most sensitive. So at the other end, we'll turn the signal generator down, and we'll see what we get at this end. To standby, squelch to threshold, signal generator back on, Yeah, about as lousy as the Audioline I was working on. About 1.3 microvolts. Anyway, we'll see how that works around Scratchy Corner. We're done. So that's a great improvement. He's got transmitted audio back. He's got public address back. Power supply set up right. And we've ended up changing 1, 2, 3, 4, 5, 6 capacitors there, and the 3 capacitors in the power supply. Right, I'll put the bottom on and then I'll take some photographs of those switches. Okay, so we've got a new screw in just there. So that's now bolted back to the heatsink. That's absolutely vital. The only thing holding it there was the heatsink compound. But when I tipped it up to do the capacitor, the mica washer, the insulating washer, fell out. I thought, hang on, where's that come from? So it's not the first one that's snapped. If these get over tightened at the factory or subsequently, they can be liable to snap. So it's a nylon insulating screw. Right, so there's the hoppy device. Let's plug it in. There you go, 5.5 watts without the radio doing anything. So if you leave that plugged in, 5.5 watts. You add that over 365 days at 24 hours a day. If we switch the radio on, it's 10 watts. And if we go into transmit, it helps if I have a mic plugged in, doesn't it? Right, transmit, 27 watts. Receiving, hasn't really changed it from squelched. There we go, little bit of a test for you. We'll get this put back together. Right, we'll just do this, these threads because they've had the self-tapping screws in them. Yeah, that's probably too large. Yeah, let's hope that we can get them to grip. I just need to take that photo and we'll put the missing case screws in the back as well. So, where are we? Let's have a flick round. One liner Roger. Notice the bar out on the display. $19 Roger. Notice it also reads 3 on the meter, even though you saw me calibrate it to 4, which goes, of course, to prove, how I say time and time again, it means absolutely nothing as to whether that swings right across, banging across, or whether it only just reads 1. It doesn't mean you're giving less power out or more power out. It's how it's set. That's a relative power meter. It's relative to SWR. So that's only correct when it's on a dummy load. So we're doing on the air test, and There we have it, the Uniden Uniace 300 late version. I think they must have been about 1983, those. Thanks for watching.